Okay, so we're going to do your parabola notes, and these are written in the conics form. And you can see it looks a lot like some of the other equations that we've had for conics. So this is a parabola that's going to open to the left or to the right, and you can tell that because it's the y that's squared instead of the x. First thing I want you to do is find p. So you can see the negative 12 is factored out from the x term, and 4p is in the same place as negative 12. So you set 4p equal to negative 12. And then just divide to find the p-value. So the p is a constant that you're going to use to find some important things in your parabola. All right, the next thing you want to find is your vertex. And your vertex, you find it the same way you would find the center of a circle or an ellipse. It's going to be the opposite of the number with the x and the opposite of the number with the y. So your vertex is h comma k, if you're comparing here. And in this case, it's going to be 2, negative 5. So I'm going to take that 2, negative 5, and I'm going to graph it over here. All right, so if I just wanted a very general idea of what the parabola looks like, I know where the vertex is, and I know it opens left or right. And because this number that's factored out from the x is negative, I can tell that it's actually going to open to the left. So if you had to make a really quick sketch of it, you would just graph a parabola that opens to the left over here. But we can get a little bit more exact. This is what we're going to do. We're going to graph the focus next. Okay, so the focus, you take the h and you add p to it. Remember, we found that p earlier. And then the y-coordinate is still going to be k. So my h is 2 and my p is negative 3, so if you add those you get negative 1. And then you keep the same k, which is negative 5. Okay, and I'm going to graph that point. It's going to help us. The focus and a line called the directrix together, that's going to help us find more points. So I'm going to use orange here. And I have negative 1, negative 5. All right, who has a question so far?
How did you get negative 1?
So the formula for the focus, if your parabola is opening to the left or the right, is h plus p for the x value. So the h was 2, and the p we solved for, we found that's negative 3. So I added the 2 plus the negative 3. All right, then the directrix is going to be a line. It's going to be a vertical line in this case. And it's going to be x equals h minus p. So it's the equation of a line. You need the x equals right there. X equals, and then what do we have? We have 2 minus negative 3, so x equals 5. Okay, and we're going to graph that one. It's a line, remember. Bless you. Bless you. Okay. So we know that it's going to open to the left, and what we want is another set of points for this parabola without having to plug in. So we go back to the definition of a parabola. When you have a parabola, all of the points on the parabola are the same distance from the focus as they are from the directrix. So you can see that the vertex here is 3 away from the focus and it's 3 away from the directrix. To get another set of points, I'm going to write this down. You want to find the absolute value of p and double it. So that's going to be absolute value of negative 6, bless you, which is 6. Okay, so from the focus, go up 6 and down 6. So look what happens when we do that. From the focus, I'm going to go up 6, and I'm going to go down 6. I have to kind of estimate down here. Okay, and now you have a set of points. This is 6 away from the focus, and it's 6 away from the directrix. And so you can sketch this in. Thank you. Okay. So I'm going to pause there to make sure that you got that. The last thing we need to do for problem 1 is the axis of symmetry. Okay, and that's going to cut your parabola exactly in half, like that. And you can look at the graph and you can just see that it's going to be y equals -5. And so it's going to go straight across here. So the parabola is symmetric to this line. All right, so take a minute to copy down problem 2, and I want you to follow the exact same steps. You can see that it's still the y that is squared. You're still going to start by finding p, and then find your vertex, focus, directrix, find your extra set of points, and then graph your parabola. And then when you're done, you can graph your axis of symmetry. Okay, so in problem 2, we're going to find p. So 4p equals 8, and p equals 2. Your vertex is going to be 1, 3. For your focus, you're going to do h plus p, so 1 plus 2 is 3. So your focus is 3, 3. Your directrix is going to be 1 minus 2, so it's the line, x equals -1. And I'm going to do that before I do the other set of points. So I have a vertex at 1, 3, a focus at 3, 3, a directrix at x equals -1. So I can see that it's going to open to the right, but I'm going to get one more set of points. I'm going to take absolute value of 2p, so 2 times 2 is 4. And from the focus, you want to go up 4 and down 4. So this one was my focus. Go up 4, go down 4, and then sketch your parabola. All right, what questions do you have on 2 before we go on to 3? All right, if you go ahead. Question? Okay, in 3, you can see it's different because now it's the x that's squared. So you're going to expect basically what used to happen to your x happens to your y. Take a minute to write down both the general form and our specific problem here. And we're going to still start by finding p. So we're still going to set 4p equal to 2. And you get p equals 1/2 or 0.5. Okay, your vertex is still HK, but notice that now the x is over here. So you get -4, 3. All right, and because it's going to open up or down, your focus is going to have the same h value, but it's the k that you add p to. So k plus p is your y value. So the x-coordinate stays -4, and then the y-coordinate is going to be 3 plus 0.5, so it's 3.5. And this time your directrix is going to be horizontal. So y equals k minus p. So that would be 3 minus 0.5, so y equals 2.5. So let's graph that before we go any further. I'm going to graph my vertex. And my focus. And my directrix. Okay, so we still want to find 2p for another set of points. And 2 times 0.5 is 1. So instead of going up and down from the focus, I'm going to go left and right from the focus. So go left 1 and right 1 from the focus. Okay, and we forgot to do our axis of symmetry for number 2, but let's do this one first, and then we'll go back to the other one. So since your directrix is horizontal, your axis of symmetry is going to be vertical. Okay, x equals -4. All right, so we'll leave that for a minute. We'll go back and do our axis of symmetry for problem 2. And then you'll have more practice with parabolas in your review packet. You'll find that there are a couple of parabolas on the back of that. There's even one where you need to complete the square. Did you guys find the review problem where you need to complete the square? Which one is that? 22, yep. All right, let's just go back to number 2. Your axis of symmetry would be right here. Axis of symmetry. Y equals 3. All right. Who has a question on parabolas? Okay. Yeah, 1 sec.